This is a complete schematic of the DC power supply. As you can see from the schematic, the list of components are 1 230 volt AC to 12 volt AC step down center tap transformer, 4 rectifying diodes, you can choose IN4007 as a good choice, 2000 microfarad capacitors having voltage ratings of 30 volt each, 4 voltage regulators 7805, 7812, 7905 and 7912, and 4 1 microfarad capacitors each having a voltage ratings of more than 30 volt, and obviously you require a few wires. Let's come to the circuit. The first stage of the circuit is the transformer stage. Here we will be using a step down transformer, and it also is a center tap type. The job of the transformer is to convert the 230 volt AC input to 12 volt AC output. The 230 volt AC voltage comes from your wall socket. The current rating of the transformer must be chosen according to the maximum current required by the user. This is a very important point. You must note that the current rating of the transformer must be chosen according to the maximum current required by the user. As you can see from the waveform, which shows the input and output voltage of the transformer, the output of the transformer is just a step down version of the input voltage. Here one important thing to note is that you must ground the center tap terminal to ground. Here, as you can see in the diagram, the center tap terminal is grounded. Let's come to the next stage of the circuit, which is the rectifier. A bridge rectifier is used for the rectifying purpose. The job of the rectifier is to convert the step down AC voltage from transformer to pulsating DC. Here now I will explain the working of the rectifier. Here you can see when the potential of terminal A is greater than terminal B, then diodes D1 and D4 are forward biased, whereas D2 and D3 are reverse biased. So the current flows from terminal A, then to diode D1, then through capacitors C1 and C2, then through D4, and ultimately it reaches terminal B. So in this case the current flows from C1 to C2. Let's take the reverse case. When the potential of terminal B is greater than A, then diodes D3 and D2 are forward biased, whereas D1 and D4 are reverse biased. So the current flows from terminal B, then through D3, then through capacitor C1 and C2, and then it goes through D4 and then it reaches terminal A. One important thing you must note here that in both the cases where D1 and D4 are forward biased, and in the second case where D3 and D2 are forward biased, in both the cases the current flows from C1 and C2. This is the ultimate job of the rectifier, that it converts the alternating signal to a unidirectional DC signal. In both the cases it flows from C1 to C2, that means it is a unidirectional current. You can see from the waveform the output of the rectifier. As you can see, the input is a alternating signal and the output is a pulsating DC output, which is our requirement. Now the next part of the circuit consists of two capacitors C1 and C2, each of 1000 microfarad. This capacitor smooths the ripples of the pulsating DC and gives a smooth, or rather close to smooth DC output. So now the potential across C1 is around 16 volt but not 12 volt. I will explain you why this is around 16 volt but not 12 volt. Actually what we are stating in 12 volt is the RMS value of the alternating current, but the peak value is around 16.2 volts. The capacitor here smooths the peak value of the voltage. It doesn't smooth to the RMS value, but it smooths to the peak value. So the peak value is 16 volt. So the potential across C1 will be 16 volt and potential across C2 will be minus 16 volt. Now as you can see, the next part after the capacitor is the voltage regulator part. What are voltage regulators? The voltage regulators give a constant output voltage when the input is greater than the particular threshold. Now what about the threshold? Now as you can see, the IC7805, which is a plus 5 volt voltage regulator, for 7805 it will give constant output voltage of plus 5 volt DC when the input is greater than 7 volt. For 7812 it will give a plus 12 volt DC constant output when the input is greater than 14 volt. Similarly for 7905 it will give a minus 5 volt DC when the input is less than minus 7 volt, and for 7912 it will give a minus 12 volt DC constant output when the input is less than minus 14 volt. So as I told you earlier that voltage across C1 is around 16 volt. So it's greater than the thresholds of both 7805 and 7812. Similarly, the voltage across C2 with respect to ground obviously is minus 16 volt. So in this case also the voltage input to the IC 7905 and 7912 is less than their threshold respectively of minus 7 volt and minus 14 volt. So as the thresholds are reached, then 7805 will give a positive 5 volt DC output, 7812 will give a plus 12 volt DC output, and 7905 will give a minus 5 volt DC output, and 7912 will give a minus 12 volt DC output. Now what are the job of these capacitors of capacity of 1 microfarad each? These capacitors tries to improve the transient response of the circuit. Okay, so now the discussion of the complete circuit is over. So you can take a snapshot of this circuit and try to build up your own. It's very easy. Just you require a few components, and obviously you need some patience, and